So for the second part of the chapter 7 notes, we're going to talk about an oxidation number, or an element's charge. So ions make charges based on it wanting to be electrically configured like a noble gas. And if you recall, here are our noble gases. So let's talk about fluorine. So if you look over here, fluorine is atomic number 9. It kind of looks like this if you look at it at the subatomic level. Fluorine has, when it's neutral, 9 protons. That'll never ever change. It's got 9 electrons. Out of those 9 electrons, there are 2 in the inner shell and then 7 in the outer shell or energy level. So if fluorine wanted to be like a noble gas, it could be either like neon or like helium, because those are the 2 noble gases that are around it. So here's neon, here's helium. Now, atoms typically only gain or lose valence electrons, and valence electrons are those outer energy level electrons. So if you recall, fluorine has 7 valence electrons, and fluorine's a halogen. These are your halogens. They always have 7 valence electrons. So here's what you need to know. Since fluorine has 7 valence electrons, it can either gain 1 electron to have a full octet like neon, or it can lose all 7 of those electrons, and then it would have that full energy level, because this inner energy level would be its outer level, and that would be electrically like helium. Well, which is easier, to change in 1 thing or to change in 7 things? Well, it's easier to change just 1 thing about an atom. So it's got this 1 singular empty space, and it's easier just to pull 1 electron and fill that spot, so it's filled like this, rather than get rid of all 7 things. So once you gain an electron, here's how we do our math here. We still have 9 protons, but we now have 10 electrons. So 9 positive charges, 10 negative charges results in a -1 net charge. So fluorine with a -1. Let's go over some more examples. So group 1A metals. Hydrogens, I'm going to group it here, but I can actually act a little differently too. But these all have the electron configuration of some noble gas, and then whatever the next energy level, S1. So it all has 1 electron outside of what a noble gas has. So they all have 1 valence electron. They all kind of look like this. And in general, what they're going to do is they have the choice of losing that 1 electron or pulling in 7 more to have a full shell. Now remember, hydrogen's a little different because it would be pulling in 1 to be like helium, so it can do a little different. But besides that, from lithium down, they'll always do this. Lose that 1 electron, now it has a positive charge because it lost a negative. So they all make a +1 cation, and we show that with just a plus sign. For group 2A metals, they all have this S2 besides their noble gas underneath them, so they all have 2 valence electrons. Is it easier to lose 2 or gain 6 to have that full octet? Well, it's easiest to lose 2, so that gives it a 2+ charge, because he lost 2 negative charges, so they all make 2+ cations. Our transition metals, they can make many charges because they have 2 valence electrons for the most part. Some of them sometimes have 1, but they could lose those 2, they could lose 1 of them, they can lose some of the D electrons, so they can make +1, +2, +3, +4. I've seen +6 cations. It just depends, and you're going to learn how to identify them, what charge they have later in the notes. For group 3A, they're going to have this electron configuration. Some noble gas, so whether it's the 2 that helium has, the 10 that neon has, but they always have 2 in the S and 1 in the P for those valence electrons, so they have 3 valence electrons. They look like this. What's easier, to lose 3 or gain 5? Well, it's easier to lose 3. So it's 3+, so they make 3+ cations. When they have D block electrons too, sometimes they can make other charges. The general rule is a 3+. There's this thing called a pseudo-noble gas electron configuration. So once you have those D electrons included, and sometimes F electrons as well, you'll notice that these will still become cations, but because they have the D or sometimes F block electrons, they'll have electrons that the noble gas before it doesn't have. So let me give you an example of what that means. I also want to identify the word pseudo means fake. So it's electrically like a noble gas, kind of. It's a fake noble gas electron configuration. So let's talk about gallium. Gallium's right here, atomic number 31. And if we write out the electron configuration for gallium, it's going to look like this. Well, when gallium makes an ion, it's part of this group 3A, so it has 3 valence electrons. Here they are, 4s2 and 4p1. See the 2 and the 1 electrons, that's 3. When those are lost, it becomes that 3+ cation. So when it has that 3+ cation, the electron configuration is this. Notice we lost our 4s2 and our 4p1, but we kept this 3d10. There's no noble gas that has the 3d10 electrons and then no 4p6 or 4s2. So there's nothing that has 28 electrons total that's a noble gas. So if you add these up, that would be 28. That doesn't exist. So that's why we call that a pseudo noble gas, because no noble gas actually has that exact configuration. Okay, so then we have group 4A, and 4A is everything under carbon. So these have this electron configuration, whatever the noble gas is, 2 in the S shell, 2 in the P shell, that's 4 valence electrons. Now some of them are going to have D electrons or F electrons, but in general, this is the form, but they all have 4 valence electrons. Since it's 4, they have the option of losing 4 or gaining 4 to lose everything, or gain to get to the full octet. And they actually could do either, because either is equal, so they can make +4 or 4- anions. So +4 cations, 4- anions. All right, 5A, nonmetals, and they're nonmetals for the most part. They have this electron configuration in general. Again, these from here down would have D and sometimes F electrons as well, but they all have 5 valence electrons. So if you have 5 electrons, you have the choice of losing all 5 or gaining 3 more, and then it's easier to gain 3. So it's actually going to pick up 3 electrons. Each electron has a negative charge, so we have -1, 2, 3 that we added on, so it's a 3-. So they make 3- anions. Anions because they're negative. Group 6A, they have this electron configuration. So like sulfur, for example, has neon, 3s2, 3p4, the 2 and the 4, those are your valence electrons. That's 6 valence electrons. So are these going to lose 6 or gain 2 to have your full shells? And it's easier to gain 2. So since we picked up 2 electrons, we've got a 2- charge. That would be considered an anion. And the last group we're going to go over is going to be our halogens in group 7A here. So they, for the most part, have this electron configuration. They have the valence electrons, 2 in your S, 5 in your P, and that gives you 7 valence electrons. You're going to lose all 7 or gain 1. This is like what we did earlier with fluorine. Of course, we're going to gain 1, which gives us a negative charge. Whenever you have a 1, you don't write the number. You just put the charge. So these all make -1 anions, just written as a negative sign.